So let's calculate the reduction potential for the half cell. Correct? Half cell means only one cell is given to you. Two cells should be there, cathode and anode, but here only one cell is given to you. That is called as half cell. Right? Now what is the given data here? Is E degree copper 2 plus 2 copper. E degree value means standard condition, which is already given in the electrochemical series. Right? That is given as 0.34 volt for copper. Temperature is given to you as 298 K. But you can see the concentration of copper ions is not equal to 1 molar. It is given as 0.01. Right. So it is non-standard condition because all the three conditions should be satisfied, like temperature, pressure and concentration. Right. So here we will use Nernst equation. What you have to calculate is reduction potential. So we use Nernst equation, but temperature is already given to you as 298 K. So we will use the third equation of Nernst. Right. So I'll just write the equation first. E cell is equal to E degree cell minus 0.059 upon N log of Q. Hope you remember this equation. In the previous video only we derived this. Correct? How we got this value also. So E cell we need to find. Correct? ERP, reduction potential of the cell, we need to calculate. E degree, it is given. Correct? E degree of the cell, that means of this cell, it is given as 0.34 minus 0.059 upon N is the number of electrons. Now here how many electrons are there? 2. Correct? 2 into log of Q. Correct? Log of Q. Now how to calculate this Q? What is Q here? So Q is nothing but it is product upon reactant. Remember this, for half cell it is product upon reactant. Now what is this product and reactant here? So write this equation first. We know Cu2 plus, it is getting converted to Cu. So Cu2 plus, it gets converted to Cu. Correct? So what it will do? It will gain electrons. Gain electrons, it is reduction. 2 plus to 0 charge. Reduce. Correct? The charge is 2 plus. Here no charge. So it is reducing. Reduction. So it gains 2 electrons here. Right? So we get number of electrons also 2. This is how we got number of electrons 2. Now what is the product here? Cu is the product here. For finding Q, you first have to write the equation. What is product? It is Cu. Correct? What is product? It is Cu upon what is reactant here? It is Cu2 plus. Right? Now, Cu, that is solid. The rod, it is solid. So the concentration of solid, we always take it as 1. The solid, nothing is written now, so it is solid. We always take it as 1. And 2 plus means it is in the aqueous form and its concentration already given to you 0.01. See, it is already given. Correct? So now into what is value of Q here? 1 upon 0.01. 1 upon 0.01. Correct? This is the value. Right? Now hope you can calculate this. This is log of 1 upon 0.01. Correct? Log of Q is 1 upon 0.01. Now how to calculate? 0.34 minus 0.059 upon 2. Log of the 0.01, 1 upon this. What will be this value? It is 100, right? This is what? 100. 100 can be written as 10 to the power 2. See, if you calculate this, you get 100. 100 can be written as 10 to the power 2. Correct? 10 to the power 2. Now, log 10 to the power 2 means I can take this 2 on the left hand side, log of 10. Log of 10 is what? 1. So what is left here? Only 2. So multiplying and subtract, finally you get the answer as 0.28 volt. So just a question I have given here, how to calculate for the half cell, how to calculate the E cell based on the Nernst equation. Always remember, for a solid the concentration is always taken as 1. So let's check now how to calculate for the full cell. Full cell means what? Both the side the cells are given, one is anode, one is cathode. Now 2 lines I have written here means it is a galvanic cell. Both the cells are given zinc and copper. This is the representation of galvanic cell also. And zinc 2 plus ions, the concentration is given as 0.01 molar. Copper 2 plus, the concentration is given as 0.1 molar. Correct. Now again the temperature is given to you as 298 K. Concentration, we can see it is not equal to 1 molar. So we will be using Nernst equation. And what you have to calculate is ERP. Correct. That you have to calculate. Reduction potential you need to calculate. Now one more data given to you is E degree of zinc 2 plus to zinc is minus 0.76 volt, and for copper it is given as plus 0.34 volt. Correct. Now for full cell, what we will do is Q is equal to anode by cathode. Correct. In the previous one for half cell, Q we take it as product upon reactant. Full cell we take it as concentration of anode upon concentration of cathode. Correct. Temperature is already given to you 298 K, but the other datas are not same. So we will use Nernst equation, right? We'll use Nernst equation and the same third equation, that is E cell is equal to E degree cell minus 0.059 upon N log of Q. Correct. Now E cell we need to calculate. E degree cell. Now here 2 cells are there. Correct. So use the first equation. Hope you remember this. If you remember, E cathode minus E anode. Correct. Galvanic cell, this side will be anode, this side will be cathode. You remember, E right minus E left. Correct. So E degree cell. What is E degree cell? Both the values given to you. So cathode value it is 0.34 minus of minus 0.76. You get it as 1.1 volt. So E degree cell is 1.1 minus 0.059 upon N. Number of electrons is 2. Log of, what is Q value now? Q is anode by cathode. Correct. It is anode by cathode. Concentration I have written. Concentration of anode by cathode. So concentration of anode is what? 0.01 upon concentration at cathode is 0.1. Hope you can calculate this. Finally calculate and you get the value as 1.12 volt. Please check the answer. So Nernst equation, it can be done only when the conditions are not standard. Correct. E cell we can calculate in 2 ways. One is for the standard conditions and non-standard conditions. Standard condition means what? It is already given. Non-standard condition means we use Nernst equation. Correct. And 3 Nernst equation already derived. Please learn the formulas, use it accordingly and calculate the numericals.